Hello everyone. Today let us discuss about law of conservation of energy. The statement goes like this: the total mechanical energy of an isolated system is conserved or remains constant. Energy can neither be created nor be destroyed in any process but can be converted from one form to another form. Let us prove today. Now, I have taken here the diagram for the conservation of energy. Here, let us take one object whose mass is m. It is thrown from a height of h. Let us consider a body of mass m dropped from the point A at a height h above the ground. Now, you can see it from this figure. Here, it is thrown from the point A. Therefore, the velocity at the point VA becomes 0. Now let us start our proof. When it is thrown from A, we have to prove that energy is conserved at the points A, B and C. We have to show the total energy remains constant at the point A, at the point B and at the point C also. For that we have to show mathematically. So let's start our discussion here. Now I'll start with at the point A first. At the point A. Now, total energy is always the sum of kinetic energy and potential energy. So, it is PE, that is potential energy, plus kinetic energy KE. And we all know the formula for potential energy, which is mgh, and the kinetic energy is half mv square, but at the point A it is va square. But just now I said that at the point A, when something is thrown from a height, velocity always becomes 0. So here va is equal to 0. Therefore, total energy is equal to mgh plus half m into 0 square, which is equal to mgh. So at the point A, total energy is mgh. Let it be equation number 1. Okay, since Va is equal to 0, here the total energy is equal to mgh. Now we have shown here at the point A, total energy is mgh. Now let's proceed. Now let's proceed to the next point at the point B. At the point B. So now let's proceed. Now at the point B, as the body falls down, it travels a distance of x. I'll take you to the top and show you the figure. So now you can see clearly here. It travels a distance of x here. Here I have shown x is the distance. As the body comes from A to B, it travels a distance x, which I have shown here. When the body comes to the point B, it travels a distance of x, that is from A to B. From A to B, clearly you can see here, it travels a distance of x. So now let's go down and prove at the point B what happens. Now if you see at the point B, here let us start. At the point B, total energy is equal to again sum of kinetic energy and potential energy. Now if you see now, from ground it is at a height of h minus x. You can clearly see here the point B is at a height of h minus x from the ground. The height of the point B is h minus x and it travelled a distance of x from the point A. Therefore, let us see now. Kinetic energy is now half mvb square and potential energy is mg h minus x. Now let it be equation number 2. And we know the fundamental equation v square minus u square is equal to 2as. At the point B, it traveled a distance of x. Just now I have shown you that. At point B, it traveled a distance of x here. So, if you see here, clearly, very clearly, it traveled a distance of x. From ground, it is at a height of h minus x. Okay. So, now let us go down and write v square minus u square is equal to 2as. For that, let us take now vb square. Initial velocity is 0 when something falls from a height. 2g, the distance travelled is x. Therefore, vb square is equal to 2gx. Let it be equation number 3. Now substitute equation 3 in equation 2. Then it will become total energy is equal to half m vb square means 2gx plus mg h minus mgx. Here you can clearly cancel 2 and 2 and it will become Te is equal to mgx plus mgh minus mgx. Now very clearly you can see here mgx minus mgx, they get cancelled and you will get total energy is equal to mgh. Let it be equation number 4. Now finally we have to go for the next one before going to that. So this is the formula for the total energy at the point B. Now let's go for the next one. So that is at the point C. At the point C means where is the point now? The point C is on the ground. On the ground means height is equal to 0. Clearly you can see here height is equal to 0. When height is equal to 0, potential energy mgh, which is 0 because h is equal to 0. Now at the point C. Yes. Now let's start again. At the point C, once again, total energy is equal to kinetic energy plus potential energy. That is half mvc square plus potential energy mgh. As already I told you, at the point C, height is equal to 0. When height is equal to 0, half mvc square plus mg into 0, it will become half mvc square. Now let us see what is vc square. Once again, let's go for our kinematic equation. V square minus u square is equal to 2as. That is vc square minus, because something is thrown from the height, initial velocity is 0. That is 2g. The distance travelled is the total height, which is h. Therefore, vc square is equal to 2gh. Now let it be equation 5 and let it be equation number 6. Now substituting equation 6 in equation 5, we get total energy is equal to half m vc square means 2gh. When it is 2gh, here 2 and 2 gets cancelled and once again you will get mgh. So here what happens now? The total energy, once again it is Te is equal to mgh. Let it be equation number 7. Okay, so now this is the total energy at the point C. Now from here what we learn? Now if you go first to the point A, at the point A, so at the point A, very clearly you can see here that the total energy is mgh. And when you go to the point B, the total energy here also it is mgh. And when you go to the point C, the total energy, once again here also it is mgh. So from these equations, that is from the equations, so what are these equation numbers? That equation number 1, the equation number 1, and equation number 4, and equation number 7. So from the equations 1, 4 and 7, we can conclude that total energy is mgh. That means at the 3 points we have shown that the total energy is same. Therefore, our law of conservation of energy is verified. Thank you for watching. We will meet in the next video with some other topic. God bless you all.